Hello everyone. So welcome to the 24th day of the December coding challenge of LeetCode. And today's problem is swap nodes in pairs. So first let us see what's the problem and then we'll discuss the solution. So the problem says that we have a linked list and we want to swap every two adjacent nodes of the linked list and return its head, right? So I'll explain what it is trying to say. That says this is my linked list. So now it has two pairs, 1 and 2 and 3 and 4. So we want to reverse the pairs without actually reversing the complete linked list, right? So I want to reverse 1 and 2 individually and then 3 and 4, and then we want to connect them. So my final linked list will be 2 1, which is the reverse part of 1 and 2, and then 4 3, which is nothing but once we reverse 3 and 4 we'll get this, right? So now I hope the problem is clear now. So now there are two ways of solving this problem. You can solve this problem iteratively, which means like you can start from the head, you can keep on reversing the pairs, and you can keep moving forward. The problem or the issue with this approach which I can see is that when you are moving forward, you will have to keep a track of the previous pointers, because say you have reversed 2 and 1. Now when you move forward, you have to fix the next pointer of 1, right? Because next pointer of 1 will be broken or will be changed when you have reverse 1 and 2, right? So it will complicate the things. The approach which we are discussing today is recursive, and it is very much easier to understand, because what recursive approach is doing is it is assuming that we are just reversing the pair, right? Because we have broken down the problem into sub problem, and the sub problem is just reverse the pair, and once that is done, move forward. And when we are reversing the pair, we are returning the head. So in that way, we are not bothered about the complete linked list, we are just reversing the pair and returning the head. And that simplifies the approach as well as it is easier to understand, right? So let's see how can we do it. So first we'll check if my head is null, which means I have no node available with me. So if that is the case, I will just return null, right? Once that is done, we'll get the next node. So I'll say list node next is equals to head dot next, right? So this is my head. Now I have taken the next node, right? So once that is done, I'll check if next is null. Why we are doing this? Because it is quite possible that we have just one node in our linked list. So if that is the case, then return head, because if we have only one node, we will not have to reverse anything, right? So we can just return the head. Now finally I'll say list node next is equals to next dot next. Okay, why we need this? So I have head pointer, I have next pointer, I am now taking the next. Why? Because once I will reverse 1 and 2, this link will break, or this pointer will break. So I don't want to lose the remaining part of the linked list. So I have now taken a reference for this node, right? So I have just taken a pointer to this node so that I have something which I can use to keep track of the linked list, or like move ahead in the linked list, right? Now we will just reverse the nodes. So I'll say next dot next is equals to head, right? So I have said next, which means 2, next is 1. So this pointer I have fixed. Now I have to fix the one pointer. So this first pointer I have fixed, I need to fix this pointer, which means the pointer of next of 1. So what is next of 1? Next of 1 is something, this is the most important point which you have to understand. Next of 1 is something which will be the reversed head of the remaining linked list, right? I'll explain again. So 1 and 2, so this is my head, this is my next, I have reversed them, which means I have said that next, which means next of second is 1, but I am not sure what to keep in the next of 1, because that will be the result or the head of the remaining linked list. But I already know how to solve that problem, right? Because that is my recursive algorithm is doing. So I'll just simply say that head dot next is equals to swap pairs. I hope this is clear. And what I need to swap is next, right? I need to swap this remaining part, right? So I already have the reference. So for this reason, I kept this reference, right? And I will just return next. So head is now no more the new head of the linked list. The next will be the head. So this was my next. Now next is the new head. So I will return next. So let's see if it works. Right? Let's see if all the test case passes. Cool. So just to reiterate what we have discussed till now, if my linked list is empty, I will return empty. If my linked list is only having one node, I will return that node. If not, I will reverse the two node. When I am reversing, I am not sure what will be the next pointer of my reversed part of the linked list. So I will just say that reverse the remaining part and set the next pointer to the head of the remaining part. As simple as that, right? And that is the solution. So I hope the solution is clear to everyone. Thanks for watching. See you in the next lecture. Bye.